This is a little bit more advanced problem than we normally encounter in introductory chemistry. But I want to go over it because if you can see it, a lot of times it makes more sense when you're actually doing the electron configurations. So we're going to actually build a table. And in doing so, this should help you visualize what's going on. So we know that we have N, which is our principal quantum number. We have L, we have M sub L, and we have M sub S. Now, N is always given to you. So in this case, N equals 4. Now for L, L values run 0 to N minus 1. So I start with 0, 1, 2, 3, because 4 minus 1 is 3. Now for M sub L, each one of the M sub L's correspond to one of these L values. So what we're going to do is we're going to go from negative L to positive L for each one that we wrote in L. So 0 is just 0. For 1, you'll go negative 1, 0, 1. Negative 2, negative 1, 0, 1, 2. Negative 3, negative 2, negative 1, 0, 1, 2, 3. Now, M sub S is your spin. So those are those pluses and minuses or those arrows that one went up and one went down when we did our orbital diagrams. So for every M sub S, you get a plus or a minus 1/2. So each time I see a value over here on M sub L, it gets a plus or minus 1/2. So I'm going to pause this, and when you come back, everything will be all filled out. So here's what you should finally come up with your pluses and minuses of 1/2. I left off a minus there. So now, what does that mean? Well, that means if I see a 0 over here, when you think about it, this is the S orbital, because I have one up and one down. And if I have L equals 1, this would be your P, 2 would be your D, and 3 would be your F. So you can always check your answers. This is the largest that I would ever ask you in a course like Introduction to Chemistry. If you're doing general, of course, we could expand on this. So hopefully that will help you to understand how you get those variables and what they are.